Introduction to AI, Artificial Intelligence. Now, AI enables us to build amazing software that can improve healthcare, enable people to overcome physical disadvantages, empower smart infrastructure, create incredible entertainment experiences, and even save the planet. Now, what is AI or artificial intelligence? So simply put, AI is the creation of a software that imitates human behaviors and capabilities. Key workloads include machine learning. This is often the foundation for an AI system. This is the way we teach a computer model to make predictions and draw conclusions from data. Anomaly detection, the capability to automatically detect errors and unusual activity in a system. Computer vision, the capability of software to interpret the world visually through cameras, video, and images. Natural language processing, the capability for a computer to interpret written or spoken language and respond in kind. Knowledge mining, the capability to extract information from large volumes of often unstructured data to create a searchable knowledge store. Thanks for watching. I will see you in the next lecture. Understand machine learning. Machine learning is the foundation for most AI solutions. Let's start by looking at a real-world example of how machine learning can be used to solve difficult problems. Sustainable farming techniques are essential to maximize food production while protecting a fragile environment. The Yield, an agricultural technology company based in Australia, uses sensors, data, and machine learning to help farmers make informed decisions related to weather, soil, and plant conditions. So how machine learning works? So how do machines learn? The answer is from data. In today's world, we create a huge volumes of data as we go about our everyday lives. From the text messages, emails, and social media posts we send to the photographs and videos we take on our phones, we generate a massive amount of information. More data still is created by millions of sensors in our homes, cars, cities, public transport infrastructure, and factories. So data scientists can use all of that data to train machine learning models that can make predictions and inferences based on the relationships they find in the data. For example, suppose an environmental conservation organization wants volunteers to identify and catalog different species of wildflower using phone app. First, a team of botanists and scientists collect data on wildflower samples. Second, the team labels the samples with the correct species. The labeled data is processed using an algorithm that finds relationships between the features of the samples and the labeled species. The results of the algorithm are encapsulated in a model. When a new sample are found by volunteers, the model can identify the correct species label. These are simple steps on how the machine learning works, okay? With the help with other parties or teams. Now, machine learning in Microsoft Azure. So Microsoft Azure provides the Azure Machine Learning Service, a cloud-based platform for creating, managing, and publishing machine learning models. Azure Machine Learning provides the following features and capabilities. So here, let's have a look. The feature, automated machine learning. The capability, this feature enables non-expert to quickly create an effective machine learning model from data. All right, so you can see that non-expert will quickly create an effective machine learning model from the data you have, this is the feature, automated machine learning. Now another feature, Azure Machine Learning Designer. So a graphical interface enabling no-code development of machine learning solutions. We have data and compute management. It is a cloud-based data storage and compute resources that professional data scientists can use to run data experiment code at scale. We have the pipelines feature. Data scientists, software engineer, and IT operation professionals can define pipelines to orchestrate model learning, deployment, and management tasks. So it will make things faster and quicker. Alright, thanks for watching. Understand anomaly detection. Imagine you are creating a software system to monitor credit card transactions and detect unusual usage patterns that might indicate fraud, or an application that tracks activities in an automated production line and identifies failures, or a racing car telemetry system that uses sensors to proactively warn engineers about potential mechanical failures before they happen. These kinds of scenarios can be addressed by using anomaly detection, a machine learning based technique that analyzes data over time and identifies unusual changes. So first, sensors in the car collects the telemetry, such as engine revolutions, brake temperatures, and so on. An anomaly detection model is trained to understand unexpected fluctuations in the telemetry measurements over time. If a measurement occurs outside of the normal expected range, the model reports an anomaly that can be used to alert the race engineer to call the driver in for a pit stop to fix the issue before it forces retirement from the race. Now, anomaly detection in Microsoft Azure. In Microsoft Azure, the anomaly detector service provides an application programming interface API that developers can use to create anomaly detection solutions. So we will handle that here, like just a quick overview about it, no worries. All right, I will see you in the next lecture. Understand computer vision. Computer vision is an area of AI that deals with visual processing. Let's explore some of the possibilities that computer vision brings. The Seeing AI app is a great example of the power computer vision designed for the blind and low vision community. The Seeing AI app harnesses the power of AI to open up the visual world and describe nearby people, text, and objects. Computer vision models and capabilities. Most computer vision solutions are based on machine learning models that can be applied to visual input from cameras, videos, or images. The next following slides will describe common computer vision tasks. So let's have a look. First, image classification. Image classifications involves training a machine learning model to classify images based on their contents. For example, in a traffic monitoring solution, you might use an image classification model to classify images based on the type of vehicle they contain, such as taxis, buses, cyclists, and so on. So you can see here from the image, this has been defined as taxi because it has a yellow or orange color, as well as it has this icon or this thing on it. All right. Object detection. Object detection machine learning models are trained to classify individuals' objects within an image and identify their location with a bounding box. For example, a traffic monitoring solution might use object detection to identify the location of different classes of vehicle. So here you can see that the camera or the monitoring has been detected. So here you can see this is a car, this is a bus, and here you can see this is a bus as well. This is a cyclist as well as this one. All right, so this has been detected. Semantic segmentation. So it is an advanced machine learning technique in which individual pixels in the image are classified according to the object to which they belong. For example, a traffic monitoring solution might overlay traffic images with mask layer to highlight different vehicles using specific colors. So here you can see the bus has been defined as red, the car as blue, the cyclist here as green. All right, and here you can see the other bus here above here has been defined as red as well. Image analysis. You can create solutions that combine a machine learning models with advanced image analysis techniques to extract information from images, including tags that could help catalog the image or even descriptive captions that summarize the scene shown in the image. So here you can see that from this image, a person with dog on the street. You can see this has been detected. Now we have face detection, analysis, and recognition. So face detection is a specialized form of object detection that locates human faces in an image. This can be combined with classifications and facial geometry analysis techniques to recognize individuals based on their facial features. So you can see that here, all of these people has been on their faces. We have, as you can see, a yellow square here. Okay, all of these people. Now we have optical character recognition, the OCR, which is very popular. So optical character recognition is a technique used to detect and read texts in images. You can use OCR to read text in photographs, for example, road signs or storefronts, or to extract information from scanned documents such as letters, invoices, or forms. So here you can see this in this image. This has been detected, as you can see, the Toronto Dominion Bank, as you can see. Computer vision services in Microsoft Azure. Now, Microsoft Azure provides the following cognitive services to help you create computer vision solutions. So the service is computer vision, the capabilities. You can use this service to analyze images and videos and extract descriptions, tags, objects, and text. This is called the computer vision. We have another service called custom vision. This service is used to train custom image classification and object detection models using your own images. We have face. The face service enables you to build face detection and facial recognition solutions. We have a form recognizer. Use this service to extract information from scanned forms and invoices. Now, all of these services, we will have a quick look into it as an overview, no worries. But for now, follow me in this. I will see you in the next lecture. Understand natural language processing, NLP. The natural language processing, NLP, is the area of AI that deals with creating software that understand written and spoken language. NLP enables you to create software that can analyze and interpret text in documents, emails, messages, and other sources, interpret spoken language and synthesize speech responses, automatically translate spoken or written phrases between languages, interpret commands and determine appropriate actions. For example, Starship Commander is a virtual reality VR game from a human interact that takes place in a science fiction world. The game uses natural language processing to enable players to control the narrative and interact with in-game characters and Starship systems. Now, natural language processing, NLP, in Microsoft Azure. In Microsoft Azure, you can use the following cognitive services to build NLP solutions. The service is language. This service is used to access feature for understanding and analyzing text, training language models that can understand spoken or text-based commands, and building intelligent applications. We have translators. Use this service to translate text between more than 60 languages. Speech. Use this service to recognize and synthesize speech and to translate spoken languages. We have Azure Bot. This service provides a platform for conversational AI, the capability of software agent to participate in a conversation. Developers can use the bot framework to create a bot and manage it with Azure Bot Service integration, back-end services like language, and connecting to channel for web chat, email, Microsoft Teams, and others. So these are the services: the language, the translator, speech, and Azure Bot. Thanks for watching. Understand knowledge mining. Knowledge mining is the term used to describe solutions that involve extracting information from large volumes of often unstructured data to create searchable knowledge store. Now, knowledge mining in Microsoft Azure. One of these knowledge mining solutions is Azure Cognitive Search, a private enterprise search solution that has tools for building indexes. The indexes can then be used for internal-only use or to enable searchable content on public-facing internet assets. Azure Cognitive Search can utilize the built-in AI capabilities of Azure Cognitive Services such as image processing, content extraction, and natural language processing to perform knowledge mining of documents. The product's AI capabilities makes it possible to index previously unsearchable documents and to extract surface insights from large amount of data quickly. Thanks for watching. Challenges and risks with AI. Artificial intelligence is a powerful tool that can be used to greatly benefit the world. However, like any tool, it must be used responsibly. The following tables show some of the potential challenges and risks facing an AI application developer. Now let's have a look about it. So here you can see that bias can affect results. So for example, a loan approval model discriminates by gender due to bias in the data with which it was trained. Error, another challenge, errors may cause harm. An autonomous vehicle experiences a system failure and causes a collision. Another challenge, data could be exposed. So, a medical diagnostic bot is trained using sensitive patient data, which is stored insecurely. Another challenge, solutions may not work for everyone. A home automation assistant provides no audio output for visually impaired users. Another challenge, users must trust a complex system. An AI-based financial tool makes investment recommendations. What are they based on? Another challenge, who's liable for an AI-driven decisions? An innocent person is convicted of crime based on evidence from facial recognition. Who is responsible in that case? Thanks for watching. Understand responsible AI. At Microsoft, AI software development is guided by a set of 6 principles designed to ensure that AI applications provide amazing solutions to difficult problems without any unintended negative consequences. First, fairness. AI systems should treat all people fairly. For example, suppose you create a machine learning model to support a loan approval application for a bank. The model should predict whether the loan should be approved or denied without bias. This bias could be based on gender, ethnicity, or other factors that result in unfair advantage or disadvantage to specific groups of applicants. Azure machine learning includes the ability to interpret models and quantify the extent to which each feature of the data influences the model's prediction. This capability helps data scientists and developers to identify and mitigate bias in the model. Another example is Microsoft implementation of responsible AI with the face service, which retries facial recognition capabilities that can be used to try to infer emotional states and identify attributes. These capabilities, if misused, can subject people to stereotyping, discrimination, or unfair denial of service. Reliability and safety. AI systems should perform reliably and safely. For example, consider an AI-based software system for an autonomous vehicle or machine learning model that diagnoses patient symptoms and recommends prescriptions. Unreliability in these kinds of systems can result in substantial risk to human life. AI-based software application development must be subjected to rigorous testing and deployment management processes to ensure that they work as expected before release. We have the privacy and security. AI systems should be secure and respect privacy. The machine learning models on which AI systems are based rely on large volumes of data, which may contain personal details that must be kept private. Even after the models are trained and system is in production, privacy and security need to be considered. As the system uses new data to make predictions or take action, both the data and decisions made from the data may be subject to privacy or security concern. Inclusiveness. AI systems should empower everyone and engage people. AI should bring benefits to all parts of society regardless of physical ability, gender, sexual orientation, ethnicity, or other factors. Transparency. AI systems should be understandable. Users should be made fully aware of the purpose of the system, how it works, and what limitation may be expected. We have accountability. People should be accountable for AI systems. Designers and developers of AI systems solutions should work within a framework of governance and organizational principles that ensure the solution meets ethical and legal standards that are clearly defined. The principles of responsible AI can help you understand some of the challenges facing developers as they try to create ethical AI solutions. Thanks for watching.